This short video is going to be covering the skeletal structures of the sternum and the ribs. The first skeletal structure that I'm going to cover is the sternum. The sternum is the breastbone of the body involved in anterior protection and joint attachment on the anterior thorax. The sternum is made of three fairly distinct parts: the manubrium on the superior portion of the sternum, the sternal body, and then the xiphoid process. The xiphoid process is typically cartilaginous through youth and into young adulthood, and typically ossifies around between 35 and 45 and fuses with the sternal body after that point. On the lateral portions of the sternum, we're going to have costal notches. You'll notice as we look here that there are going to be 7 costal notches on the sternum. Those 7 costal notches are going to be because they articulate with the 7 true ribs of the body. So as we move into ribs, we are going to have 24 total ribs, 12 each side, or 12 pairs, however you would like to think of it, a pair being a left and a right at each thoracic level. We're going to have the 7 true ribs, 3 false ribs, ribs 8, 9, and 10, and 2 floating ribs, ribs 11 and 12. True ribs are such called because they directly articulate with the sternum. Our false ribs will articulate with the rib directly above them, leading up to true rib number 7, which will articulate with that final costal notch here on the sternum. But rib 8 will articulate with rib 7, rib 9 will articulate with rib 8, and rib 10 will articulate with rib 9. Our floating ribs are thus called because they do not have an anterior articulation, but rather terminate in the abdominal muscular wall, and thus just sit here without any anterior point of attachment, hence their names floating ribs. This slide is once again going to just reinforce the fact of the true ribs, false ribs, and floating ribs here. This image from a superior view on top is going to help us identify the 2 points of attachment for each rib with its thoracic vertebrae. So the thoracic vertebrae, many of the ribs throughout the thorax are going to attach to 2 thoracic vertebrae via a superior and inferior demicostal facet. But each rib will only articulate with a single transverse process of a thoracic vertebrae as it's angled up and then comes anteriorly. So each rib will only have 1 point of attachment on a transverse process, while it may have 2 points of attachment at the head of the rib. This slide here is going to help remind you of the structures that you should be learning in lab for each rib. And the last thing that I would like to cover as part of the sternum and the ribs is the idea of the motion that can occur because of the joints that are found here, particularly during breathing. So during normal inhalation and expiration, we are going to have small amounts of rib movement. We are going to have small amounts of rib movement at their posterior, at the posterior portion of the rib, at its, the costovertebral attachment. I had to think of that name. At the costovertebral attachment, there's going to be a small amount of movement that occurs here via a plane joint or a gliding joint. So if you'll remember back to our first discussion, this is a synovial joint. These are synovial joints, is what I should say. And there's going to be a small amount of movement that occurs here, which leads to large amounts of movement that occur as we come anteriorly on the rib. Similar to the idea of a door as it hinges, the movement at the hinge is fairly minimal, but it can result in gross amount of movement or large amounts of movement at the end portion of these ribs. So there's 2 types of motions that occur in the ribs. At the more superior ribs, we're going to have more of a pump handle motion where the ribs are going to move up. And then as we move more towards the inferior portion of the inferior ribs, the ribs are going to have more, they call it a bucket handle movement, where the ribs are going to move up and out. So it's going to translate into outward movement. So each rib individually only will accomplish a small amount of movement, but together, when we put them all together collectively, it can result in a fair amount of volume change within the thoracic cavity during breathing. This motion is controlled by our diaphragm as well as our chondral muscles, our internal and external intercostals, and our innermost intercostals. I went and found a couple of videos to try to help highlight this. So I'll go ahead and play this and we can kind of watch as it goes through. So what I want you to notice is the small amount of movement that may occur at this posterior attachment as it goes through. And then the costal cartilage, which you'll remember is a synchondrosis, it doesn't actually, it's more for stability. It doesn't create the movement, if you will, but it allows for flexibility when the motion occurs, when the muscles pull. It allows for flexibility while maintaining stability of the ribs. So I'll fast forward just a little bit here, get back to our breathing. So as we breathe, the ribs translate into this pump. Let me back up a little bit. This is that pump action and a bucket handle more down here. Bucket handle, and this is more of the pump where they're just coming up, and the bucket handle is kind of an up and out motion. I'll get that one more time. So this is typically during breathing. I pulled up one last video because I wanted to put it all together with the diaphragm. So this is a 3D figure and representation of how the diaphragm is going to pull up and out and going to allow the ribs to create that movement. And during heavy activity, our intercostal muscles will also kick in to really exaggerate this inhalation and expiration. So I'll let this play. So as the diaphragm pulls down, it's going to expand the rib cage. So that's the pump action and the bucket handle action where the volume increases, pulling air into the lungs. And then as the diaphragm relaxes here and comes up, we're going to, our rib cage is going to come back to its initial resting state where it's more of a, I don't want to say compressive, but the volume is less than when we inhaled. So I'll let that play through here just for a moment. You can see the movement of those ribs and how that motion of the diaphragm here and its attachment at this bottommost portion of the thorax as it comes all the way around can create that movement throughout the rest of the cavity. So a little bit of a different view here that we can see and appreciate. And that wraps up this video covering the sternum and the ribs.